Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field. Here we are again in Scout Valley Provincial Park, and what we can see here is a little bit of that shoreline feature. So you can see a bit of a hill here. It's just a little mound, and all I see is really sandy soil. And I bet this was the spot you'd put up your sun chair, your umbrella, maybe crack a cold one, and sit back and relax on the shoreline with the waves crashing down below, not too far from here. You can see this beautiful fine to medium grain sand. Oh, this is great sand. And the beauty, the engineering link here is that we always need sand when we construct our roads, when we build foundations, we need lots and lots of sand. So finding a beach deposit like this that isn't at the beach anymore is a tremendous find, because we can excavate it. This is a provincial park, so obviously it's protected, but out there in private land or whatnot, this is what you're trying to look for, is a beach deposit, because we need all that sand for the construction and the things we're going to build. That's the engineering link. All right, we're just about 100 meters up from that beautiful sand that had coarse to medium and fine sand, no gravel, no cobbles, and here we go. We've got a pile of cobbles, we've got gravel on as far as I can see. So we've moved up the shoreline, higher energy up here, probably a source rocks up further that is being sort of washed down, perhaps when there's storms and whatnot, or just a different stage in the shoreline. We've got higher energy here because we've got lots of coarser fragments exposed. Now we can see they're fairly well rounded. We've got cobbles, we've got boulders, and we've got gravel, and it's mixed in with the sand as well. So we've got a whole mix here at the shoreline, a little bit further up from that very sandy shoal that we saw out there. Knowing that in this environment we can find well-rounded cobbles, which can be a very useful aggregate source for construction, and riprap that can protect against erosion. That's the engineering link. We want to protect against erosion by placing these cobbles in places where we have high currents. Maybe when it rains, we can protect the slope by placing these cobbles. They're an excellent engineering material to find. So ancient shoreline environments, tremendously good source of aggregate. We've seen sand, we've seen gravel, we've seen cobbles. All right, we've got a nice exposure here of the actual shoreline. You can see the roots were just below the vegetated surface here, it coming down over a ridge, and that's a great place where we can see the soil exposed at the surface without having to dig any holes or anything like that. I was just walking along, saw a ridge, thought I'd come over. There's a bit of an erosion pathway here. People have been walking down here to the creek down below, but it's exposed the soil here on the side, and we can see we got gravel fragments here and sand interspersed with lots of rounded cobbles and even some larger boulders up there. And this is a great exposure to show you what the soil's like and the variation in the grain sizes. And the rounded cobbles and boulders tell us that this material has been transported a long distance, or it's been worked a lot at the shoreline here on Glacial Lake Algonquin. So we have to determine whether it's till or whether or not it's actual lake sediments. And in order to do that, with till would be really highly compacted and dense. We might even have a lot more coarser fragments, but majority of these fragments, they're well rounded, and that tells me they've been sitting on the shoreline getting washed about in the waves, maybe even transported by a river down into the lake. So they may have had an origin from the glacier that pushed them here, but that glacial Lake Algonquin persisted well after the glacier is retreated, and so these may then have been reworked glacial material, and now it's a coastline deposit. We use our geological knowledge, that knowledge of geological processes, to deduce what's happened to this material, and then we can understand where we are in the environment, and that is what we need to understand for our projects that we're building, or if we're trying to source material. So this is great aggregate resource because we probably don't have a lot of clay fraction in this material. Of course, what we need to do is take it to the lab and do some analysis, but you're going to learn about that in third year. All right, we've gone up the coastline, probably another couple of 100 meters from where we last left off, where we had mostly just cobbles and gravel. And remember, before that, 100 meters further south, we had pure sand. Now we've got even coarser gravel, well rounded for the most part. As you can see, there's a lot more gravel present as well. And now we've even got some bigger boulders here. We've got a fabric here, and I'll zoom in a minute. We've got a fabric standing up vertically, and we've got alternating light and dark minerals. So this isn't limestone. This has to be a metamorphic rock. All right, not too far from where we were, further up the shoreline, we've got a sand and gravel pit. You can see in the distance a couple of towers. They're sorting and processing the material there. You can see different stockpiles, probably different grain sizes. And up here, they've got just the raw material that they're excavating. You can see gravel and sand and cobbles and boulders. They've got to take it over to that plant, and it'll be a screening plant where they're sorting the different grain sizes. And that's what you got to do in order to use it for an engineering material. You got to sort it into appropriate grain sizes for your project.